Hello, everyone. It's my honor to have this opportunity to share a method for the forensic diatom test with you. Many thanks to the invitation from Dr. Sarah Spalding and the Diatom Web Academy. I'm Sunlin Hu, a forensic scientist with Minxue Scientific Company. My talks include 4 parts: principle of the forensic diatom test, conventional methods for the test, the improved SEM-based method, and its potential value for other diatom-related applications. Now, let's come to part 1, principle of the forensic diatom test. The number of joining cases each year is surprisingly high. According to the World Health Organization, 372,000 people die from drowning every year. That is 42 drowning deaths every hour, which means bodies found in the water are not rare. The circumstances of bodies in water fall into 3 categories. Suicides. In this category, the cause of death is drowning. Accidents. In this category, the cause of death is also drowning. Homicides. In this category, the cause of death may be drowning or not. In some cases, bodies were dumped into water after death. One of the foremost tasks for forensic doctors when facing a body recovered from the water is to determine the cause of death. For a flesh-drowned body, there are various signs with the body, such as foam from the nose, lung edema. These signs can be utilized for drowning diagnosis, but in forensic practice, more than 80% of the bodies found in the water are highly putrefied. Typical signs of drowning disappeared due to putrefaction. Consequently, the diagnosis of drowning is always one of the difficult issues in forensic medicine. The diatom test has been considered as an important approach in drowning diagnosis and routinely used in many forensic labs worldwide. In this review, published in 2005 on the prestigious journal Forensic Science International, the forensic diatom test is even considered as the golden standard. As is well known to everyone, diatoms are a kind of single-celled organism, exist widely in rivers, lakes, and seas, with approximately 75,000 species, mostly ranging from 2 to 100 micrometers in size. They contain siliceous frustules and possess characteristics such as anti-acid corrosion, sensitivity to water quality, porosity, and light capturing, which enable them to be widely applied in various fields, including forensic science. This picture shows the principle of the diatom test. Under circumstance 1, that is drowning, due to breathing, diatoms in the water will enter the respiratory tract and lungs, penetrate through the alveolar capillary barrier, enter the blood, and flow throughout the body with the systemic circulation. Therefore, diatoms can be detected in organs and tissues such as lungs, liver, kidneys, bone marrow, etc. While under circumstance 2, namely post-mortem immersion, the dead body is placed into water. Diatoms may passively enter the lungs, but cannot disseminate in the circulatory system as the heart is not beating. Therefore, diatoms usually cannot be detected in the liver, kidneys, and bone marrow. In addition to drowning diagnosis, diatoms can also be used to infer drowning site, as diatoms vary from location to location. The diatoms in the body should match those in the drowning site. Moreover, diatoms at the crime scene may have been transferred onto the clothes or other items of the suspect. Therefore, diatom evidence can link the suspect to the crime scene. Now, in part 2, I will describe how the diatom test is performed conventionally. The whole process can be divided into 3 main steps. The first step is diatom extraction. To use an electric hot plate to heat the mixture of tissues and strong acids, such as nitric acid. Organic matter will be destroyed and become liquid, while frustules will remain in the liquid. The second step is diatom concentration, to concentrate the diatoms in the liquid by centrifugation. The last step is diatom analysis. To use a light microscope to detect diatoms on a slide prepared after centrifugation. A China standard for the test was published in 2009. The protocols used in other countries are quite similar. These conventional methods satisfactory in terms of accuracy, efficiency, convenience, safety, and economy. Above all, sensitivity is crucial in the forensic diatom test, as can be seen from this diagram. Usually, there are a large number of diatoms with various shapes and sizes in a drowning medium. A larger part of them can enter lungs and stomach, but only a very small number of tiny diatoms can enter liver, kidneys, and bone marrow. For drowning cases, the positive test rate reported in literature varies considerably, but overall is very low. It's widely accepted in forensic practice that this rate is close to 1/3. While for non-drowning cases, some researchers detected diatoms in lungs and closed organs. Due to the high rate of false positive results and false negative results in casework, the diatom test's validity has always been controversial since the test was first proposed by Ravensdorf in 1904. In history, this controversy was called the war on diatoms by some forensic pathologists. In addition, the test is harmful and time-consuming. A large volume of hazardous gas is emitted during the chemical digestion, and usually a couple of days is required to complete the test for the case. So conventional methods are not ideal for the test. The only advantage is for the required instruments is low. Currently, the test is used mainly in Europe and Asia, but in North America or South America, it has not been adopted as a routine procedure in forensic practice. Next, I'll move on to introduce the improved SEM method developed by our team at the Guangzhou Forensic Science Institute, China, where I worked from 2002 until 2018. I started the methodological research on the diatom test in 2003 when an SEM was equipped at my lab. At that time, I was also a PhD student. And in 2009, I completed my dissertation titled The Application of Two Microbeam Analytical Techniques in the Diagnosis of Drowning. In this dissertation, the MDVF auto-SEM method based on microwave digestion, vacuum filtration, and automated SEM was proposed. In the following, I will call it the new method for convenience. There are also 3 steps as conventional methods, but heating digestion, centrifugation, and LM in conventional methods are replaced with microwave digestion, vacuum filtration, and auto SEM respectively. This method has become the new China standard for the forensic diatom test since 2019. So what improvements have been made with the new method? Let's look at the foremost advantage, sensitivity. As mentioned above, conventional methods are not sensitive. In comparison, the new method has improved the positive test rate to 95% or above from 1/3 for drowning cases, which is a significant breakthrough. The rationale behind high sensitivity is the combination of new techniques for the test. Firstly, microwave digestion. It's a highly efficient digestion technique with less use of samples and efforts. One of its important advantages is strong digestion ability. Fatty matter in tissues of liver, kidneys, and bone marrow are difficult to be digested by conventional methods. However, can be dissolved completely, which enables more diatoms to be harvested. This picture shows a layer of fatty matter suspending on the top after heating digestion. Routinely, this layer is separated and discarded. An experiment was done to evaluate the rate of diatom loss. After a sample was digested by heating digestion, the lower layer, part A, was filtered, followed by auto SEM, while the upper layer of fat, part B, was further digested by microwave digestion, followed by vacuum filtration and auto SEM. After that, the rate of diatom loss due to heating digestion can be calculated. The result is shown in this table. As can be seen, the diatom loss rate ranges from 7 to 45%. The second cause behind the high sensitivity is vacuum filtration. According to our experiments, about 35% of diatoms are lost for centrifugation at 4,000 RPM per time. The routine process of centrifugation for 3 times is likely to result in a loss of approximately 75% of diatoms. In order to avoid diatom loss caused by centrifugation, we designed a simple vacuum filter using membranes with the pore size 0.45 micrometer. Since nearly all diatoms are larger than that size, this filter, in principle, is able to collect 100% of the diatoms in the liquid. This vacuum filter was later modified and commercialized. The last cause behind the high sensitivity is auto SEM. SEM has the advantages of high magnification and high resolution compared to LM's usual maximum magnification of 1,000 times. SEM can magnify a sample tens of thousands of times easily. Thus, every detail of diatoms can be observed clearly under SEM, which is ideal for diatom identification and classification. Another advantage of SEM is large depth of field, which is 300 to 1,000 times that of LM. For LM, diatoms at different levels on the slide need to be focused one by one. But for SEM, due to its large depth of field, diatoms at different levels can be detected at the same time with no need to refocus. For this reason, diatoms are not likely to be missed. We designed the following workflow for the diatom analysis. First, the membrane is divided into a number of fields automatically at a relatively low magnification, for example, 600 times. Then the fields are scanned and the images are saved automatically. For lung or water samples, the random scan mode is usually selected in that the diatom concentrations for these samples are pretty high in most cases, and it is not realistic to analyze every diatom. But for closed organ samples, such as liver, kidneys, the membrane must be fully scanned, as usually only a few diatoms exist on it. The remaining steps had to be done manually. Every diatom-shaped particle will be labeled, like particle 1 and particle 2, and the coordinates will be recorded. Next, these particles will be revisited, and the high magnification images will be captured for identification and classification. We use this formula to calculate the concentration of diatoms in tissue or water samples, where C is the concentration of diatoms in tissue or water samples. N is the total number of diatoms detected. W is mass of tissues or volume of water samples. Then statistical analysis can be done with the obtained data. In the end, a report with the qualitative and quantitative result will be produced. We did a series of experiments to see for the same prepared slide with no cover slip, how different the quantities of the diatoms detected respectively by LM and auto SEM would be. Here are the results. This is for concentrations of diatoms in water samples, and the ratio, the average ratio is 32%. And this is for concentrations of diatoms in liver tissue samples. The ratio, the average ratio is 37%. As can be seen, most tissue samples of or water samples less than half of diatoms in them could be detected by LM compared to by SEM. Besides sensitivity, the new method is more efficient. The time required for the test is about 1/5 of that required for the conventional test. As far as simplicity is concerned, this new method is quite straightforward. There's no repeated procedure. In comparison, the actions of refilling methods, multiple time centrifugation, multiple slide observing are needed for conventional methods. With regard to acid use, less than half of acid amount is needed for microwave digestion, and the closed microwave digestion is less harmful. Therefore, this method is superior to conventional methods in terms of sensitivity, efficiency, simplicity, safety. The weak point is that although SEM is costly, we have established the demo labs at the Guangzhou Forensic Science Institute and the Southern Medical University, China. The joint lab at the university provides the services of the diatom test, training, and R&D. This method has been used in over 50 forensic labs in China and helped identify the cause of more than 2,000 water-related deaths. Below is one of them. A female student from a university in Guangzhou disappeared on September 12, 2015. 2 days later, the body was found in a lotus pond near the campus. Investigations indicated this was a homicide. No diatoms was detected in the closed organs of the victim, which supported that the victim was killed and subsequently dumped into the water, while the diatoms detected on the suspect's pants and shoes matched those in the water of the pond, which linked the suspect to the crime scene. In 2017, the suspect was convicted of murder and sentenced to death. In 2018, the invention of this method and a series of related research by our team at the Guangzhou Forensic Science Institute won the second prize of the National Science and Technology Progress Award, which is one of the highest honors in science and technology in China. However, there are still pain points with the new method regarding diatom analysis. The test is still labor-intensive with many manual steps, and the technician has to be good at diatom classification. Moreover, although SEM's cost is high, therefore we are trying our best to develop economic and intelligent auto SEM for the test. We are cooperating with SEM manufacturers such as TestScan Czech, CIQ Tech China, Diatoms China to make auto SEM systems for the test as economic as possible. Up to now, we have developed 3 types of systems. Among them, 2 was based on standard SEM. 1 is based on tabletop SEM, which is much cheaper than standard SEM. For these systems, we have automated all steps by combination of digitalized SEM, diatom database, and AI. Here is a video demonstrating how they work. We invited a third-party certifying institution to test these systems. The testing result shows that the overall correct rate was over 90%. These are the diatom images taken by these systems. They were purchased and used in about 10 forensic labs in China. Not many, but you know, these systems were just released recently. So what's next for the forensic diatom test? I have worked in this area for 20 years. I and my colleagues intend to do two things in the following years. One is to continue to improve the new method to make it more intelligent and accurate. The other one is to conduct more research and try to establish a reliable positive test threshold for joining diagnosis. The current ones were all based on conventional methods. Is the forensic diatom test indeed valid for joining diagnosis? My vision is to get the war on diatoms solved eventually by working together with colleagues worldwide. Lastly, I would like to speak a few words about the new method's potential value for other diatom-related applications. Take water quality monitoring, for example. In Europe, there are two diatom-related standards being used for water quality assessment. The first one is about sampling and the preparation of benthic diatoms from rivers and lakes. The second one is about the identification and the enumeration of diatoms. For the first standard, the procedure also includes 3 steps: diatom cleaning by heating digestion, centrifugation, and slide preparation. My suggestion concerning these steps are that, firstly, use microwave digestion for the first step. Actually, this technique is being used at ANSP. Secondly, use vacuum filtration to avoid diatom loss. Thirdly, prepare a sample for SEM additionally. While for the identification and the enumeration procedure of the European standard, it is laborious. At least 300 diatoms need to be observed manually for each sample, which is likely to bring about high fatigue for operators. My suggestion is to try to develop auto LM or auto SEM to make the diatom analysis easier. As shown above, conventional procedures cause significant analytical errors, and the new method is better in terms of accuracy. To what extent will this improved accuracy impact the indices for water quality assessment? I hope this research can be done in the near future. There are limitations for this method in casework. Firstly, only the upside can be seen. In comparison, the frustule is transparent to LM. Both valves can be observed, which is critical for diatom classification. Second, even the most economic tabletop SEM costs at least $60,000 US. Although SEM is still expensive. In summary, the MDVF auto SEM method is sensitive, accurate, highly efficient, is promising to help solve the long-standing diatom war in the future. Moreover, it is helpful to get more accurate data for determination of diatom indices for water quality monitoring and other diatom-related applications. loss has potential value in these areas. This is all the content of my talk. My email address is shown here. If you have any questions, please contact me. Thank you so much.
Sunlin, thank you very much. I really enjoyed your presentation. We'll let folks collect their thoughts, and if they want to ask questions, feel free to raise a hand or type a question. I would like to ask you a question first, Sunlin. See, most of the time we know diatoms to be used in ecology. Are there police officers or detectives who are becoming educated on diatoms a little bit and you know, collaborating with the medical universities to answer these questions?
I just mentioned this test has not been adopted as a routine test in the United States, but in China or other countries in Asia, it is widely used. So most forensic doctors will send samples to a diatom lab for analysis.
Great.
What's your question? Sorry.
No, you answered it. It sounds like the police are collaborating with researchers to analyze the diatoms. I was asking if there happened to be any police detectives who were training themselves in diatoms, but it sounds like it's a collaboration between the police and the research institutes.
Yes, yeah.
Becky Bixby asked a question: if you have used flow cytometry for diatom analysis in tissues?
Yeah, and I used to have a flow cam system. Do you know flow cam?
Yes.
Yeah, but the magnifications are too low for detect diatoms in tissues accurately. So we give up.
Yeah, it's very nice that you have this process automated with the SEM, and then you can get much higher magnification and better identification. So I see why the flow cytometry would not work. Mark Edlund has a question. He says, why have the police in North America not used these drowning analysis more readily?
Okay. I think the first reason is that there exists false positive results in casework for conventional methods. And there's another reason, that is the sensitivity of this test is very, very low. Just as I mentioned, only 1/3 positive test rate can be achieved with conventional methods. And it is laborious. All of these reasons restricted this method, this test, for being used in many countries. The most critical factor, I think, is negative, false negative how to say,
No, I
false,
understand. Yeah.
sorry, false positive result. Yeah.
No,
Maybe this is caused by contamination.
Sure. Yeah, no, I very much understand. Mark would also like to know what kind of 0.45 micron filter are you using? Are they glass fiber? Are they polycarbonate filters? What type of filter material?
Okay, PS,
Okay.
yeah.
Okay. Miriam, let's see. I have to read her question really quickly. Or if she wants to ask it, you're more than welcome to.
Sure. Actually, that might be easier. So, I thought that was very fascinating. Thank you so much for that talk.
Thank you.
I was very intrigued by the study that you were telling us about how they matched the diatoms on the suspect's shoe to the pond. And I was wondering, how specific do they have to look in the taxonomy to make a solid decision? Like, do they look at subspecies levels and varieties, or is it more general than that? Does that make sense?
Yeah, I know. I know your question. Yes. As a matter of fact, we are not very good at accurate taxonomy. And often we just identify a datum at the level of genus, general. Okay.
Mm-hmm.
Yeah. So the most important character we use is datum morphology. We will see if datums detected are look the same in morphology.
Okay.
That's what we concern most.
Okay, that makes sense. Thank you.
Yeah.
And Mark, do you have another question? I'll let you ask this one.
Yeah, I do. Thanks for your talks, and then that was interesting. I am really puzzled why in North America these tests are not being used as readily. One of the questions I have is, when you have drowning victims, you obviously have diatoms everywhere. There's diatoms on the body, there's diatoms in the clothing in the body, there's diatoms. How are you working with police to make sure that contamination is not affecting everything about the study, the case?
Okay. So because the current method is very sensitive, so contamination is a big issue. To avoid contamination, we have to prepare a control sample for during the autopsy, we have to pay much attention on contamination. Yes, so the body has to be washed completely, not only with tap water, but also with diatom-free purified water, because the diatoms can be detected in tap water. Do you understand?
Yeah.
Okay. Yeah. So we try every means to avoid the contamination, and after we get a sample, we also will get a control sample. If there are diatoms detected in the control sample, the target sample maybe not cannot be used.
Okay. Thank you for that. Can I just ask one more technical question? On the SEM preparations, are you sputter coating? Putting a small metallic coating on the sample before analysis with your current SEM setup?
Yes.
Okay.
To make it conductive.
Okay. Yeah, I was just curious if you were using
Yeah.
one of the other types of SEMs at all. Okay. Well, thank you so much.
Thank you.
I got another question too, if you want me to ask more, David.
Go for it, Mark.
So in the US, we have in criminal cases, we have oftentimes scientists are called as what are called expert witnesses to help interpret evidence and present some of the data that are being used as evidence. Does that similarly happen with your group or you in Chinese cases of this, in supporting or using diatom evidence in criminal cases?
Yes. I'm not sure if I understand your question, but let me just answer. Please see if it answered your question. I think diatoms are being used as a kind of evidence in linking the suspect to the crime scene. Just I mentioned in my presentation. This is also used. This is used in USA because I found a paper written by American policeman, and just as I mentioned in my presentation, with that case, the evidence, the datum evidence is used not only in the diagnosis of Johnny, and also used in linking the suspect to the crime scene.
Mm-hmm.
Yeah. So I think you maybe you mentioned some other evidential value for datum evidence, right?
Mm-hmm. Yes, that's what I was thinking. That
oh yeah, okay.
But when you've generated these data, are you? I'm just curious if you, as a scientist, are going into the courtroom to present these data. You understand what I'm saying? Are you ever asked to help interpret or present these data in a criminal case?
Yes, I wish. Let me see. I'm not sure if you noticed this picture. This is from ABC crime drama series. Yeah. Actually, in China, more and more scientific okay, how to say, forensic scientists are being requested to go to the court to present evidence.
Mhm.
Yeah, so just you said that if it is necessary, I think so. More and more the forensic scientists are receiving these requests.
Interesting. Thank you for that. And I love that diatoms end up on television shows a little bit sometimes too. Although as people who study diatoms, we often laugh at the pictures that they use of the diatoms because they don't make any sense. Like they have a freshwater setting for a case and they show marine diatoms in the pictures and like, wait. Thank you.
Thank you.
All right, are there any more questions for Sunlin? I'll just give folks another quick chance to formulate any questions, but Sunlin, I want to thank you very much. Thank you for speaking in English to a naive person like myself who doesn't know any Chinese. So thank you for coming and talking with us today and sharing with us your technologies and experience and how you know, diatoms can be used to help bring justice to the world. If you everyone wants to tune in 2 weeks, Samaya will be talking to us about diatoms from harsh places. And Sunlin, if you have any other final thoughts you want to share, please feel free. Otherwise, we can call it a day.
Okay, thank you.
Yeah, thank you. Is it do I say this right? Say hui?
再会. See you. Okay.